Good morning, grade 12. So, yes, we are looking at first principles today, and this has to do with differentiation or differential calculus as in textbook. And whenever we do this, we always start with the definition of a derivative. And this is on your formula sheet, so you don't have to memorize this, but you will probably memorize it by using it a lot. So, yeah. You don't need to memorize this, but we start off with this definition. And you would remember we got this from we derived this from the average gradient, and then we use limits to get all the way to there. So this is your starting point. Always first principles, you have to start there. You cannot start any other place, you have to start there. So I'm going to show you a few examples of different types of equations, and yeah, enjoy. The first one we're going to look at is if we have a constant, just like that, fx equals 7. So just for your own understanding, this is a horizontal line going through the y-axis at 7. So we know its gradient will be 0, right? But I'll just quickly prove through the first principle definition that it is so. So if fx is 7, remember there's no x there, so that means fx plus h will also be 7, as an example. So with our definition, this then means that fx plus h is 7 minus fx, which is 7. So this will be equal to 0 divided by h, which is equal to 0. And you can clearly see here that it's as we know instinctively that the gradient is 0. Okay, next example. We are going to look at a straight line graph. So let's say, for instance, fx equals 3x plus 2. You know that the gradient is 3, and we're just going to prove it just now. So if fx is 3x plus 2, then f of x plus h will be 3 times x plus h plus 2. Okay, so now we have our definition. Now we just substitute and solve. Okay, remember you have to include your limit, otherwise it's not accurate. So this is then 3x plus h plus 2 minus 3x plus 2. Now we simplify. This becomes a 3x plus 3h plus 2 minus 3x minus 2 over h. And you will see 3x minus 3x is 0, 2 minus 2 is 0, so you'll just have 3h over h. The two h's cancel out, and then you'll only have a 3 left, right? Which is then equal to 3. As mentioned when we started, you know it will be 3. So all of this is still straightforward and easy. Now we are going to do a quadratic function. So let's say fx is equal to 2x squared. I'm starting easy and we're going to build it up, okay? So 2x squared, then f of x plus h is 2 times x plus h squared, okay? And now from first principles, let's do this. over here, if x plus h is then 2 times x plus h squared minus 2x squared. Now we simplify the numerator. This becomes 2 times x squared plus 2xh plus h squared minus 2x squared. And then over here it will become 2x squared plus 4xh plus 2h squared minus 2x squared divided by h. 2x squared minus 2x squared is 0, so what will be left is 4xh plus 2h squared over h. Now we take out the common factor. Those two cancel out. So now we can substitute 0 in. So our final answer will just be 4x. Okay, now we move on to a more complex one, which looks like this. So fx is 2x squared plus 4x plus 1. And now that then means f of x plus h is equal to as I've expressed there. Okay, so let's substitute. Just going to have to create a little bit of space here. So limit h approaches to 0. 2 bracket x plus h squared plus 4 times x plus h plus 1 minus 2x squared plus 4x plus 1. Okay, so limit h approaches 0. Okay, so x plus h becomes x squared plus 2xh plus h squared. So I'm just going to multiply the 2 in directly already. So it's going to be 2x squared plus 4xh plus 2h squared plus 4x plus 4h plus 1 minus 2x squared minus 4x minus 1. Let's cancel out what we can. 2x squared minus 2x squared, they cancel out. 4x, h doesn't, okay, 4x and 4x cancels out, and 1 cancels out. So what is left then is 4xh plus 2h squared plus 4h over h. Same strategy. We cancel out the common factor, but before we can do that, we have to take out the common factor. Now we can substitute h in, which will make that one 0. So the final answer is 4x plus 4. Hyperbola function, that's the last one we're going to work with. So fx is 2 divided by x. Therefore f of x plus h is 2 over x plus h. Now let's substitute. So this will be 2 over x plus h minus 2 over x divided by h. Now we have to get a lowest common denominator for the numerator part. So this will become 2x minus 2 bracket x plus h over x times x plus h over h. Let's simplify the numerator further. 2x minus 2x minus 2h over x times x plus h over h. Then you will see 2x minus 2x becomes 0, and then we are left with negative 2h over x times x plus h, and then the over h I'm multiplying with the reciprocal, so it will become 1 over h over there. Okay, that means these two h's will cancel out, so you are left with the limit of h approaching 0 of negative 2 over x times x plus h. Now we can substitute the h as a 0 in, because it will not make it undefined, so that falls away. So we are left with negative 2 over x squared, and that's the derivative from first principles.